All right, today's lesson, we're going to take a look at vertex form and standard form. And we're going to start with the equations in vertex form, which we've just talked about in the last two lessons. And we are going to convert that or change it into standard form. So just looking at some differences between the two. In vertex form, we have the parentheses, and it's that whole thing in parentheses that's being squared. In standard form, it's just the x that's being squared. Now, both of the forms have a value of a, so that is actually the same number, the same value for a, so that's going to be similar. But we'll notice that, vertex form has plus k at the end, standard form has plus c at the end, so those are actually different things. They represent different parts of the quadratic function. So to get something from vertex form to standard form just simply means we're going to have to multiply this out a little bit. We're going to have to use what we learned in our polynomials unit to multiply the x minus h times itself. Okay, so whatever that happens to be. So what information does each form tell us? So let's look at a little comparison here. Can we tell if a parabola opens up or down when it's written in vertex form? Well, yes, it's that value of a at the beginning that tells us if it opens up or down. If a is a positive number, the parabola opens up. If a is a negative number, the parabola opens down. The same can be said about standard form. A, the number in front of the x squared term, will tell us if it opens up or down the same way. Positive opens up, negative opens down. So we can actually tell that from both forms. Now, maximum and minimum can also be discovered the same way, right? If a parabola opens up, then there's a minimum. If the parabola opens down, then there's a maximum. Okay, so that just kind of goes hand in hand. Now, the vertex of the parabola can be easily found in vertex form. It's just the numbers that are in these positions. It's the h and the k from vertex form. Now, in standard form, you can find the vertex, and we did that in the previous lesson. It's just a little bit more complicated, where we have to actually use the values of b and a with that formula to find that. So it's not as easy to find. It doesn't tell us directly what that vertex is, even though, yes, you could actually find it if you wanted to. But vertex form is much easier if you're just looking for the vertex. Now, if you're looking for the axis of symmetry, remember that's your equation, like x equals a number. And that number is the x coordinate of the vertex. So, you could find it pretty easily in vertex form. It's just, the number that's in the place of h here. So if your equation says x minus 4 in parentheses, the axis of symmetry would just be x equals 4. In standard form, you could use that same formula, the opposite of b divided by 2a, to get that same number. Okay, so it'll work the same. Maybe just not as easy to find as it is in vertex form. And the y-intercept is one that really only works in one of the forms. None of the numbers in vertex form will give you the y-intercept. Again, the value where it crosses the y-axis, or where the parabola crosses the y-axis. However, in standard form, it is always this number at the end. It's the c in the equation in standard form. So you can find the y-intercept in standard form, but not in vertex form. And then last, we have the x-intercepts. We haven't spent a lot of time talking about the x-intercept, except for the lesson where we just talked about the features of the graph. And that's really going to become important in our next unit, Unit 11, when we solve quadratic equations instead. But really, vertex form does not give us any of the x-intercepts. The standard form of the equation also does not give us any of the x-intercepts. So that one we haven't really talked about because these forms of an equation just don't really give us that information. So that's going to come in a future lesson in Unit 11. So what I'd like to do in this lesson, like I said earlier, is just convert a vertex form equation, like example number 1, into standard form, meaning it's written in order from highest degree to lowest degree. There's no parentheses. Everything has been combined that can be combined and multiplied that can be multiplied. So our 3 steps that we're going to follow is the first thing we need to do is simplify basically the parentheses. Okay, the parentheses squared part. Remembering that squared means to multiply by itself. In this example, the x plus 3 squared means that I want to multiply x plus 3 times itself. So I'm actually going to start by just writing that out so we can see what that looks like. So x plus 3 times x plus 3, and then we have the minus 14 at the end still. So we actually have to multiply this out. We have to figure out what is x plus 3 times x plus 3. So how do we multiply a binomial times a binomial? Well, the way that we did this earlier was we used the area model. Do x plus 3 on the side, x plus 3 down the top, and do your multiplications to get what's on the inside, the areas. So x times x is x squared, 3 times x is 3x, 3 times x is another 3x, and then 3 times 3 is positive 9. So we have a total area. So when I multiply together x plus 3 times x plus 3, I get x squared plus 6x when I add those 3 x's together. 3x plus 3x is 6x. And then I have plus 9 in the last box. Now that's just the part highlighted in yellow there. I still have the minus 14 as part of this quadratic function. So I simplified the x minus h squared part. Next it says to multiply by a, but you'll notice there wasn't a value in front of there. That's basically just a 1. And since anything times 1 is itself, that's already done. Next, we combine the constant terms. So that's our terms that have just a number and no variable attached to it. And that's going to give us y equals, we bring down the x squared, we bring down the plus 6x, and we add together the constant terms, 9 and negative 14, or 9 minus 14, we get negative 5. So our equation in standard form is y equals x squared plus 6x minus 5. And just for a review, just a reminder, a would equal 1, b would equal 6, and c would equal negative 5. So we can tell here that because a equals 1, this parabola would open up. Okay, it would be one like one of these. We can also tell that it would cross the y-axis at negative 5 because that is our y-intercept value, our value of c. And, if we wanted to do a little work, we could find the vertex. But really, it's probably easier to find the vertex from vertex form. It would be at the point, well, let's see. It says x plus 3 in parentheses, so I know that that first number is going to be negative 3 then. And then because my equation ends with minus 14, my y-coordinate of that point is negative 14. So I know the vertex from vertex form. I know that it opens upward from both forms. The value of a was 1. And I know the y-intercept was negative 5. I know a lot of information about these, this parabola from these different forms. Let's look at another one. The difference here is that we do have a number multiplied at the beginning. We have a value of a, in other words, from our vertex form. But we're still going to follow the same 3 steps. We're going to start by multiplying out the x minus 2 squared. So I'm going to go ahead and write this out. So I have the 3 times x minus 2, and then remember squared means times itself, so that's just x minus 2 times x minus 2. And then I have the minus 19. So somewhere off to the side, I'm going to do my multiplication for x minus 2 times x minus 2. And I'm not going to worry about the 3 yet, okay, that coefficient of 3. I'm just going to leave that there for now. All I'm trying to figure out is x minus 2 times x minus 2, just that much of it. So I know x times x is x squared, negative 2 times x is negative 2x, it happens twice, and then negative 2 times negative 2 is positive 4. So when I add that all together to get my total area, I have, let's see, putting it into my equation, y equals 3. Okay, so here is my answer, x squared minus, let's see, 2x and 2x, that's going to be minus 4x, and then plus 4. And then I have to bring down that minus 19 at the end. Sorry, it's getting kind of close there. All right, so that's step 1, simplifying that part. Step 2 is multiply by a. So now I want to take this 3 and distribute it to all 3 terms, all 3 parts of that quadratic. And when I do that, I'm going to get, let's see, y equals 3 times x squared is 3x squared. 3 times negative 4x is negative 12x. And 3 times 4 is positive 12. And then I don't distribute to the minus 19, but I have to keep that in place right at the end of my quadratic. So there's step 2, we multiply by a. Step 3 is combine the constant terms. So our constant terms are going to be the only like terms every time. That's all we have to combine at the end. So the beginning part is going to stay the same, y equals 3x squared minus 12x. And when I combine my constant terms, a positive 12 minus 19, or 12 plus negative 19, is negative 7. So in that case, my value of a is 3, b is negative 12, and c is negative 7 from standard form. So the negative 7 would represent the y-intercept of my parabola. Because a is 3, that tells me my parabola opens upward. And it also tells me that it's a, let's see, this one would be compressed together. Remember, anytime that a is bigger than 1, it shows that the arms of the parabola would be kind of pushed in and opens up. So if I were to draw a sketch of that, my regular graph would look something like that, kind of wider. But this one would be kind of stretched a little or pushed a little bit in because a was 3. And my, let's see, my vertex right at the bottom is a minimum. And if I use my values from vertex form, x minus 2, so 2 is the x coordinate, and then it ends with minus 19. So my vertex is at 2 comma negative 19. It opens upward and has a y-intercept of negative 7. All right, it's all different parts of information that we can get from both forms, or either form individually. Put it all together, it gives a pretty good picture of that quadratic. All right, let's look at one last problem, just kind of tie it all together. This time, we have a very similar equation that's still in vertex form. You know, we could look at that and identify the vertex right away. Because it says x plus 5 in parentheses, we know that that was really like x minus negative 5. So negative 5 is my value of h, and then k is 17 because it ends with plus 17 at the end of the equation. So I know my vertex, but if I want to know what are the coordinates of the y-intercept, I can't get that from vertex form. I have to follow these 3 steps and try to write it in standard form instead. So I'm going to start by just writing it out. Y equals negative x plus 5 multiplied by itself. So x plus 5 times x plus 5. And then I still have the plus 17 at the end. So let's multiply x plus 5 by itself. I'm going to get x squared. I'm going to get 5x. Another 5x. And then 5 times 5 is 25. So we get y equals negative, and here's where you have to group. Right? We need the parentheses here. I'm going to put all of this area on the inside, combining like terms. X squared plus 10x plus 25. And then I have the plus 17 at the end. Okay, so now I have to apply this negative. I basically distribute negative 1 times everything. It's just going to make everything negative. So that gives us y equals negative x squared minus 10x, because a negative times a positive 10x is a negative 10x. And then negative times positive 25 is negative 25. Bring down the 17. The last step is combine those constant terms, writing our equation. In standard form would be y equals negative x squared minus 10x. Combine my constant terms would give me negative 8. So there's my equation in standard form. What are the coordinates of the y-intercept then? 0, comma, and looks like ABC. C is negative 8. So my y-intercept is 0, comma, negative 8. So remember, if you need to find the y-intercept, standard form is the form of the equation that has that answer in it. Vertex form does not. So it is a pretty quick process to go from vertex form to standard form, and each form has its own purpose. So it just kind of depends on what you need, will kind of help you decide which form you want to use.